Good day, everyone. I've come once again to teach you today. Today, I want us to discuss chemistry. The topic we want to discuss today is oxidation number or oxidation state. So follow me. Let me explain to you what oxidation state is all about. All right, let's go. All right, like I said earlier, our topic today is what? Oxidation state. Then oxidation state, what is oxidation state? Oxidation state is equal to, it means what? Valency plus charge. Oxidation state means what? Valency plus charge. Valency plus what? Charge. All right. So when you talk about oxidation state, you talk about oxidation state of an element or an ion in what? In a compound. You talk of oxidation state of an atom in what? In a compound. For example, you may talk about oxidation state of magnesium in a compound, oxidation state of oxygen in a compound. That's oxygen atom in a compound, or magnesium atom, or sodium atom, or manganese atom, and so on and so forth in what? An atom. All right. So while finding the oxidation state of an atom in a compound, we do it mathematically. There is a way we calculate it. There is a way we do it. All right. So when you have a compound that is not charged, when you have a compound that is not charged, it means that the sum of oxidation state of that compound is what? Zero. All right. Let me show you an example so that you understand what I'm talking about. We have example 1 like this. We have example 1. Example 1 says find the oxidation state of nitrogen in the following. We have all this. We have solution like this. We have N2O. That's number A. N2O. They say we should find the oxidation state of nitrogen in this. All right. I have stated it earlier how to find the valency of first 20 elements. The valency of first 20 elements. Let me state it here once again. All right, we have the first 20 elements like this. If you want to get the valency of first 20 elements, it is very simple. So just you move from 1, you get to 0. From 0, you go up to 4. From 4, you come down to 0. Go up to 4, come down to 0. Go up to 4. That is how it is done. For example, we have like this. Here is 1, you go to 0. Then you have 1, 2, 3, 4. When you get to 4, you now come down to 0 again. You have like this. You have this 1, 0. When you get to 0, you go up to 4 again. You have 1, 2, 3. You have 4. When you get to 4, you come down to 0 again. You have like this. You have this. You have this. Then you go up again. You have this. Can you see that? So that is the simplest way of doing it. Just like this. 1, 2, 3, 4. 3, 2, 1, 0. 1, 2, 3, 4. 3, 2, 1, 0. 1, 2, 3, 4. 3, 2, 1, 0. In that order, you will get all this. All right. Then another thing is that while solving this oxidation state, sometimes you see that some atoms will have oxidation state of plus, while some will have oxidation state of minus. Then how do you know the one that will have oxidation state of plus and the one that will have oxidation state of what? Minus. That is plus and minus. Okay, let me quickly tell you. When you have this, when you are going up, what do I mean by going up? Like 1, 2, 3, 4. You are what? Ascending. You are doing what? Ascending. That's in increasing order. Anything you have there, the 1 should be what? Plus 1. The 2 there should be what? Plus 2. The 3 should be what? Plus 3, and so on and so forth. But when you are descending, for example, you are from 4 coming down, you have 3, you have 2, you have 1. All those ones should be what? Negative. But if you are ascending, it should be what? Positive. So this 1, for example, as you can see, after 0 you have 1, after 1 you have 2. We are ascending, so this one should be plus 1. You have plus 2, plus 3. But if you are now descending from 4, you get to 3. So here should be what? Minus 3. Here should be minus 2. Here should be minus 1, and so on and so forth. So as you are descending, you have what? Negative. As you are ascending, you have positive. All right. When you come here now, you notice that we have this compound, it is not charged, so it means that the total oxidation state should be equals to what? Zero. The total oxidation state should be what? Zero, because it is not charged. So we have something like this. If it has charge, that means that charge will be the value of total oxidation state. Is it clear? But here it's not charged, so we have it to be what? Zero, like this. So they said we should find the oxidation state of nitrogen here. So what do? You have nitrogen. Let me call oxidation state of nitrogen, let it be what? X. Is it clear? So you notice that this 2 is multiplying what? Oxygen. So I will have this to be what? I will have it to be 2x. All right. Then this oxygen is only one atom of oxygen. And what is the valency of oxygen? Valency of oxygen is what? 2. And this valency of oxygen is located when you are descending. That's when you are coming down. It means that these 2 should be what? -2. So because of that, I'm going to have this here, and this will give me what? Equals to 0. Remember what I said, that the total oxidation state of a compound, a neutral compound, is what? 0. That's why we have 0 here. All right. I don't have much space here, so let me continue over here. We have like this. So I have 2x minus 2 is equals to what? Is equals to 0. Let me bring it up here. I have 2x minus 2 is equals to 0. All right, this is minus. Crossing over here should give you what? To give us our plus. So we have 2x is equal to 0 plus 2. Can you see that? That means that 2x is equals to what? 2. Can you see it? All right, at this point, I'll divide both sides by coefficient of x. And coefficient of x simply means what is multiplying x, and that is what? 2. So I will have this. I say 2x divided by 2 is equals to 2 divided by 2. When I cancel this, I will cancel this. I have only x left. Dividing this and this, I will have 1. That means that the oxidation state of nitrogen here is what? It is what? 1. Is it clear? It is 1. No wonder this is called what? Nitrogen 1 oxide. Nitrogen 1 oxide. Because of this, the oxidation state of nitrogen there is what? Is 1. All right, let's go to next one, which is number B. We have B like this. B, we are looking for oxidation state of nitrogen here. Like I said, the total should be what? 0, like this. All right, like I told you earlier, this one is what? 2, and it's negative. So, and we have this one to be x. So we have x minus what? 2, like this. That is oxidation state of nitrogen. Let it be what? X. Then oxidation state of oxygen is what? -2. 2 is the valency of oxygen, because that it belongs to the valency when you are descending. That's why we attach negative sign here. So we have it to be this. All right. So when this crosses over here, we have x is equals to, we have 0 plus what? 2. We have x is equals to 2, like this. Can you see that? All right. Next one we have is ammonia, NH3. Like I said earlier, the total should be 0. All right. We are looking for the oxidation state of nitrogen, but hydrogen belongs to group 1, so it belongs to metals, so it should be positive. So we have N like this. I said let it be what? X, the oxidation state of what? Nitrogen. So for this one we have plus 1 times what? 3. Plus 1 is the oxidation state of, that valency of hydrogen is 1, and because that it belongs to group 1, which we know that they are positive because they are metals, it should be what? Plus. So you say this times this. All right, so we have this. So x, when you multiply this, you have 3 like this. Can you see it? So this is plus. Crossing over here should be minus. So you have x is equals to 0 minus 3. You have that this is equals to this. So it means that oxidation state of nitrogen in ammonia is what? Is -3. All right, we still have number D and number E left. So let me clean this side so that I will have enough space to solve these ones. All right, next one we have is NO2. So we have number D like this. We have NO2 is equals to what? 0. Let the oxidation state of nitrogen be what? X. So I have X here. All right, nitrogen, oxygen, like I said, it has valency of 2 and is negative. So you have this to be this. because we have two atoms of it, we have it like this, which is what? 0. All right, x minus 2 times 2 will give us what? Minus 4, like this. When this minus crosses over, it will become plus, so we have this to be equals to, have 0 plus what? 4, like this. Can you see that? So we have that x is equal to, have plus 4, like this. Can you see it? All right, next one we have is E. All right, E, we have it to be NO3, like this one. All right, like I said earlier, this one will give us equals to 0. Okay, so this one being minus 2, that is oxygen being minus 2. We have this one to be x. We have minus 2 times number of atoms, which is what? 3. We have it everything to be equals to what? 0. All right, so we have that x. Let me demarcate this. All right, so we have that x minus 2 times 3 will give us what? Minus 6. You have like this. Can you see that? When minus 6 crosses over, it will become what? Plus 6. So we have like this. X is equal to 0 plus 6. So it means that the oxidation state of nitrogen here is what? Plus 6. So that is how it can be solved. All right. I believe that you enjoyed the way I just solved it. Remember, this is Engineer Kenneth tutorial. Subscribe to my channel and share this video so that it will get to the right students that need to acquire this knowledge in order to get educated. Once again, thanks for watching this video. Bye.